Our next topic is the R chart. The R chart is used to monitor the variability of a process. We have two questions in mind. How can we construct a chart, and how can we use the chart to decide whether the process is in control or not? Let's take an example. A fire department is concerned with its ambulance response times measured in minutes. The target average response time is 15 minutes. Data from 5 samples appear in the accompanying table. So in the first week, we collected 3 observations. In the second week, we collected another 3 observations, etc. Part A, compute the lower and upper control limits of the R chart. So in the R chart, on the x-axis, we have every week, and on the y-axis, we have the sample range. And we also have the upper control limit and the lower control limit. So part A is concerned with computing these limits. To compute them, we're going to use these formulas. D4 times R bar, D3 times R bar. So how can we compute these? R bar is the average of all the sample ranges. So first we compute the sample range of each sample. The sample range is the largest value in a sample minus the smallest value in a sample. So in the first sample, the largest value is this, the smallest value is this, and the difference is 0.9. And we repeat this in the rest of the samples. In the second sample, the largest value is this and the smallest value of this, and the difference between the two is 0.9. And we repeat this, 3, 3.1, 4.4. And once we have all the R values, we compute the average of them. The average of these is R bar, 2.46. So that's R bar. Now, how can you find D3 and D4? We can find them in this chart. We have the size of the sample. Depending on the size of the sample, we can find D3 and D4. The sample size is the number of observations in each sample. So in our data set, how many observations did we take in each sample? 3. So the sample size is 3. So in that case, D3 is 0 and D4 is 2.575. So we can plug this into the formula. D4 is 2.5475, D3 is 0, and R bar is 2.46. So if you compute this, the upper control limit is 6.33 and the lower control limit is 0. So in the R chart, we put the sample number on the x-axis and the sample range on the y-axis. And the upper control limit is 6.33 and the lower control limit is 0. Let's go to part B. The fire department kept collecting samples as follows. Is the process in control? We already have the R chart in the previous question. So we want to use the following samples to make a decision. So for sample number 6, what should we plot on the x and the y-axis? The y-axis of the sample of the R chart is a sample range, so we need to compute the sample range for each sample and plot them. So what's the sample range for sample number 6? The largest value minus the smallest value, 2.4. And what's the sample range for sample 7? The largest value minus the smallest value, 1.9. And the largest value minus the smallest value, 3.3. Okay, so we can plot this on the R chart for sample number 6. The sample range is 2.4. For 7, 1.9. For 8, it's 3.3. Based on this, how can we make a conclusion? If one or more sample ranges are outside the limits, we conclude that the process is out of control. But we had all the sample ranges within the limits, so we conclude the process is in control.